Hey everybody, today I'd like to give a walkthrough of installing a new configuration of the Seals model. Previously, we've had people install Seals Dev, and that is the full logic of the Seals model. But oftentimes we just have a user of Seals that might want to install a simplified version that only has the code that they need to see as a part of it. And so we're going to have what we're going to call a project-specific or standalone Seals implementation. And that's what I'm going to walk through here today. So first off, the starting point is often somebody gives you a URL to a GitHub repository, and that's what we're going to start with here. We're going to, in this repository, first off, see that the README is actually going to have detailed installation steps. So first off, to note, this is, again, just the standalone Seals implementation. If you want the full Seals model to be involved at like the developer level, feel free to check out the Seals repository here. This particular walkthrough assumes that you have Git, Python, and VS Code installed on your machines. And if you don't have that, well, do it, or see this video here, which is me giving a different walkthrough of installing those things and setting them up in a particular way that we use here at NetCap Teams all the time. Okay, but for now, let's assume we have those, and we're going to start with the first line. We're going to be cloning the repository to whatever folder you want. Now, I spent a lot of time on this release making it work robustly across all operating systems and file organizational structures, which was not the case in the past. So if you wanted to, you could just install it in My Documents or whatever. But I'm actually going to illustrate it here, though, still using the preferred Teams approach to file organization. And so for that means we're going to be working in your users directory in a project called Files, and we're going to have assumed you created a project folder called Seals. So Seals might have lots of different versions of Seals or different projects or different spatial extents. And so when we actually have Seals, we're going to create a new folder called Seals Projects. Here you see all the different implementations of Seals that I have. And so this would be a bunch of different manuscripts, generates a lot of data in each of these. This is what we'll refer to as the project folder. And so for here, we're going to start totally from scratch and make a new directory here. And we're going to call this one the project folder. Being very specific on our names here. And so we could just create it here in our File Explorer, but for this tutorial, I'm going to be doing everything on the command line because that's just more powerful and flexible. So the first thing we need to do is navigate to this directory where we want to create the project folder. So you can do the easy way. I just copy the actual path and then CD for change directory and go straight there. We could make the directory then up here, but we'll just choose the command down here, mkdir, and we're going to choose a very specific name that I'll be referring to throughout, Seals CGE box. And when we run that, we can see up here, we got it. There's nothing in there, but what we're going to do is navigate into this on our command prompt. So cd seals CGE box. Now we are going to git clone, and we're going to put the project repository in the project folder. So to do that, first thing, go and copy this. I don't like typing things because I type a lot of mistakes. So I always copy and paste and type the minimal amount. So down here, we're then going to type git clone, and we're going to be pointing to the Seals CGE box dev repository. So not Seals dev, but the project specific one. Okay. And what Git has done is it's cloned it here, and we see the repository. You know it's the repository because here we're just following the convention that we'll post append it with the repo state. And so in this case, it's a developer version still. But poking in there, here you see the hidden folder if you have that enabled for that makes it a Git repository. But you'll notice it's a very light repository. There are not all that many files. And that's by design. It's going to be installing Seals in a separate repository. And so all it really has here is the configuration to get the project set up. And then also data specific to this project. It's often a bad idea to have data included in a Git repository, but this may be one case where it is okay, mostly because the data are very small and you can think of them as configuration files. Nonetheless, in this repository that we've just cloned, there is a setup environment.bat for Windows and a shell file for Mac and Linux. We're on Windows, so we're going to run this one. You could just double click it here, but we're actually going to do it down in the command prompt. So first we need to get into the repository. So cd again, seals, CGE box, dev, and you can type dir if you just want to see what's in there. And yep, we can see our setup environment.bat. You could just type setup environment.bat because we're in command prompt. If you're in PowerShell though, you need to type /dot first. This is just a safety feature. And so for compatibility, I'm also going to write it here. That just says in the current directory, we're going to run setup environment.bat. And I probably have a typo. Oh yes, / setup environment.bat. Sorry about that. Okay. And so now it's running that bat file, and it's going to do a number of things. It's going to clone the full seals dev repository, and then it's going to use conda to install it. And so first off, if we go up a level to the project folder, we see we have another repository put parallel to our project repository. So this is a full local install of the seals model. Just a side note, if you're involved at the developer level, this might look redundant to what you have. And indeed, that's true. If you're not doing a project level installation, but a full developer installation, you probably don't want to have separate repositories all over the place, and you just want to point them to the same one. For this tutorial, we're going to hold off on explaining that difference other than to say, if you're involved at the developer level, you'll probably want to do an editable install to a single repository rather than cloning it each time. But in this case, we're assuming it's just a user. Okay, so what's going on down here is it's identified the 150 or so megabytes, 330 packages of Python libraries. And you do need to hit Y, yes, to confirm. And then it's going to do some downloading and installing and linking. And what this is doing is creating a new Python environment. And this one is going to be specific for the CGE box project that we have here. If you're curious, CGE box is a really awesome set of computable general equilibrium tools, open source approaches to doing global, or not global, but general equilibrium analysis. And this is just the current project I'm working on, and so I thought this would be a good one to illustrate it. Okay, so what we've done here is we have just finished using Anaconda, specifically the MiniForge thing that we've assumed you have already installed, and installed Hazelbean, which is my personal library, as well as all of its dependencies. And so once that was done, the next thing it does is gives us some notes that we need to activate that environment. That's true. But it then goes ahead and uses pip to install an editable version of seals dev. So this one up here. And that's where it's going to do a bunch of stuff to get it actually installed. Okay. One requirement, if you're on Windows, that you may have is you need to be able to have a machine that compiles C files. And so although most of this is written in Python, the actual performance sensitive lines of code are all written in C or C++, and those need to be compiled. We use something called Cython, but that requires having a C compiler configured on your machine. So if you don't have that, what I would refer you to is go to our overall Earth Economy Dev Stack installation. You can find that at my personal website, which is justinandrewjohnson.com, software, Earth Economy Dev Stack, and let's check out the installation. And so here you'll see some very similar looking instructions, but critically, it has some information on how to install the C or C++ compiler. We even now have a one-liner using WinGit. Maybe I should have incorporated that into this tutorial, but you can go ahead and do that yourself. Regardless, Let's go back to the repository. Okay. So what actually happened is pip doing the local editable install actually compiled all the C files for us. And we can confirm that just by looking in the seals dev repository. Seals, where do we got? So here are the input C files, but it actually compiles it out to a PYD file, which is actually just a .dll file that you often see in compiled code, but a Python specific DLL one compiled for C Python version 3.12. And so if you're on a different operating system, this would be compiled into a different file, and that's why we can't just provide it, although we're aiming to do that with Conda Forge installation very soon. Okay, so those were all compiled, and now we are able to run the project-specific version. And so looking at the files here, we have a number of different configurations. We're going to start with this one here. And to do that, we're going to go down in here and critically activate your environment first. By default, your command prompt is not pointing at the environment you just created. So we're going to use conda activate, the one we just created, which we named seals CGE dev, CGE box dev env. And if you're on command prompt, you can actually see it prepended now with that name. That means now when you type Python, it's going to be pointing to that Python. And so we'll type Python and point Python to the run seals CGE box test.py and click go. So now if it's the first time, it'll take a little bit longer than next times because it's doing some pre-processing of the work. And yay, we start to get a bunch of feedback. It's a test version of this, and the test configuration just means it's going to be a smaller subset of the full problem. Just so that we can confirm it works more quickly. But the first thing you see is the project flow output. And this documents very clearly the logic of the model. And so we're going to let this run. It's already on the part where it's now going to split it into 77 different parallel tiles that it computes in parallel. Oh, that's just so fast, I don't even need to stall. It's basically then going to run those in parallel and stitch them together into a single geotiff. And that's what we have done. Okay, so now we're actually ready to talk about output. And so we ran this Python file, but what it's going to do is actually create a new folder outside of the repository, because here now we are going to follow the rule that you don't put data in a Git repository unless it's just to configure something. And so if we go out here where we get cloned our repository, you see two different folders now that are new, the input folder and the intermediate folder. So the input folder, first off, this is just a copy and paste of the one that is in the Git repository, but now you can change it without having to worry about messing up the underlying configuration. And critically, if we open up this one, test scenarios, there's a lot to explain here. There's a lot of complexity of seals. But these, in short, are the configurations. It defines the baseline, and then also defines, in this case, just one scenario, and it's going to be pointing to just 1 year, 2050. But you can follow the tutorials on the rest of the Seals project pages to learn how you can expand, for instance, to multiple time steps. And an easy way to see what that might look like is in the case of the actual CGE box project. If we successfully complete the test environment like we just did here, you now may want to run the same thing, but instead of the test configuration, we run the full configuration. It's actually identical, except for that it points to this scenarios.csv file, which has, as you might guess, more scenarios and more years. And so this just happens to be the years that were outputted in the CGE box run. So we're going to run all of them. The scenarios.csv file just tells Seals what it wants to iterate over, because you often want to run many, many scenarios. Okay. That's the input. The intermediate then is where everything happened. And a different tutorial could go through all of these different ones, but I'll show you just the conclusion, which is the stitched LULC simplified scenarios. this is the downscaled results. And so here is the base year 2017, but now we have downscaled according to the SEALS machine learning algorithm in the most likely locations where the changes that CGE box said there would be in land use change, where those are located at a much, much higher resolution. And so we have the full extent that was computed, and then we also then just clip it down to the specific polygon in question. And finally, if you really don't want to even open up QGIS, just for fun, we also then visualize it using Matplotlib and save it as a PNG. So, oops. So this is, now I've lost it on my mini screens. There it is. And so this is then the results. And you could compare this with the base year and see what the CGE box when downscaled to 300 meters resolution for all of Germany looked like. Okay, that's it. Check out the other resources if you want more information, but this is a project-specific implementation of SEALs that hopefully is a lot easier for onboarding brand new people. Thank you.